What are we doing here? We are mixing in these bottles. We have 4 bottles, and we're mixing in yeast and sugar. What do we use yeast for, Shia? Right. And how does it help? Why do we use it? Because when it reacts with the sugar in the challah, it rises by making gas. It produces a gas. We are going to produce a gas over here. We set up in a science experiment. You could do something cool, but besides doing something cool, you always have to have a control. What's a control? Control is to make sure that what you did that was cool was really happened because of what you thought made it happen. It happened because of what you thought would make it happen. So here, what do we think is making the extra air? We're going to try to make extra gas. We're going to show how the more the sugar, the more the gas we get. But in order to do that, we need to have a control. So our best control is going to be our first bottle. Our first bottle has 1 teaspoon of sugar, as well as 2 1/4 teaspoons of yeast. The second bottle is the same amount of yeast, but 2 teaspoons of sugar. But
the first one is less.
The first one just has yeast, no sugar.
You said the first one has sugar.
No, I'm sorry. The first one has no yeast, no sugar, just yeast. And the second one has yeast plus 1 teaspoon of sugar. The third one has 2 teaspoons of sugar and the same amount of yeast. And the last one will have, as soon as we could finish with this funnel, 3 teaspoons of sugar. Here's the last bottle. We're going to put in 2 1/4 teaspoons of yeast. 1, 2, and then 1/4. And what we're going to do after we do this, we're going to pour in some warm water. Sarah, the water that I put on the stove, is it warm yet? Okay, can you turn it off, please? Thank you. And we're going to put in 3 teaspoons of sugar. 1, and then we're going to put on 2, and then we're going to put balloons on top, because that's a good way of seeing how much, what are we going to see, how much gas is made. It's exactly right.
It's going to get bigger and bigger.
It's going to get bigger and bigger. I hope. If this experiment works.
It's supposed to get bigger and bigger.
Usually I try to practice my experiments ahead of time. This I did not. So we're going to see if this works.
It's supposed to get bigger and bigger.
The last time we did something without practicing, it didn't work. What was it? What did we...
The balloon with the water.
The balloon with the water. That worked pretty badly.
Yeah,
we did practice one
of them didn't pop.
Inflate a balloon under.
Yeah, one of them didn't pop. That's right. This one is not going.
You still have the balloon.
Should I try pouring it in like this?
Yes.
Yeah. No, it's not going to work. It's going to be.
No, you should shake it.
Yeah. Well, so I'm shaking it though.
Shake it.
There are pieces that keep getting caught on the bottom. No.
Oh no! You move the bottom.
Oh, that's a good idea.
Move the bottom.
No. Hold on.
Take something sharp and move the bottom.
Hey, we have a little scientist who gave us a good idea. The toothpick idea. We're gonna do that.
Right. Put something in the bottom so it will fix it.
Okay. We got some toothpicks. You know what, you could turn that off because that's boring. Okay.
Yeah, I can see it.
This is the one with no sugar, right?
Yep. No sugar.
And then we're gonna need some help. Anybody want to help me put the balloons on top of the?
I cannot.
Okay, Alia, here you go.
Mommy's watching it.
Okay, great. Thank you. Okay.
Nice, yeah.
And so they'll all have the same amount of water, the same amount of yeast. What's going to be different between them?
The sugar.
The sugar.
It's a little hot.
Okay, that's cool. Okay, who wants to put a balloon on this guy?
Have you had the balloon?
Okay, here you go. Put the balloon all the way around the lip of that, okay? And make sure not to drop it, okay?
Okay.
Thanks. Okay, next bottle. I'm going to pour some water into here, up until the same point. They're going to have the same amount of water.
Can I put on this one?
Yeah,
Have you had the
absolutely,
balloon?
Abia. You have a balloon already? Just be very careful. We don't want it to fall. Do it on the other side of the table, okay?
I want to do this one.
See that? That's how.
Can I do that? Can I put the bottom?
You can do the last one. Yeah.
Yay.
Doing it together. That's so smart. Okay.
I hold it and she does it.
Perfect.
And I'll hold it.
Guys, the door's open. Yeah, because you left it open. No, I put it open just now.
I think that's enough. Much. No, we finished everything.
No, I think that's enough. Okay. Great. And now, Scott, you want to put the balloon on?
Yeah.
Okay. You guys got your balloon? This on the side, because this is a reaction that takes some time. That's Mommy. This is going to take some time. So, and now we're going to go to the eggs.
Eggs, yay.
So tell me, please.
The egg through the bottom
Hey.
thing.
Tell me, do eggs float in water or sink in water? So
However you put it.
So actually,
Right there in the middle.
so they actually sink. They actually sink. Now, why would? Well, let's show that. Let's show that. Let's put in some water.
My lid is strong. Oh, that.
No, you're gonna make
Okay,
eggs
it's sinking,
sink.
right? How do we know whether something is going to float or sink? What makes something float or sink?
The inside of it.
It's white.
Kind of. Okay, the color actually is less important. What's?
I was in one.
Oh, it's weight. I'm sorry. I thought you said white. Sorry.
Wait.
Yeah. So
And the shape.
weight is actually important, but it's the weight compared to the weight of the water in the same amount of space. Does that make sense? So
Yes.
Yeah.
So the amount of space. Yeah.
If an egg, you take the same amount of water of an egg, exactly,
Exactly.
then
Right.
it will sink. You want
Kind of, yeah. If you take the same amount of water as the amount of space that the egg takes up, and then you see what weighs more, the amount of that amount of water or that amount of egg. If the water is heavier, then the egg will float because the water is heavier than the egg. But if the egg is heavier, then the egg will sink. Now, how can we make? And the word for that is density. Density is how much stuff, how many molecules are in an amount of space. So if there are a lot of molecules in an amount of space, that is very dense, right?
like oil and
Hold
water.
on, I need you paying attention, okay? Then it's very dense. How can we make the water denser? So that the egg will be less dense than the water, right? We're gonna try to make, hold on, we're gonna try to make the egg
Float.
float by making the egg less dense than the water. Now we can't change the density of the egg unless we like have a machine that could like compact it, you know.
Or we can attach it to something that does float.
Okay, but
then it will be in the middle.
then we're not just talking about the egg. What we can do is we can make the water more dense by adding something to the water. That won't take up more space, kind of. It'll be absorbed into the water. It'll become a solution. So what we're going to do is we're going to use salt. Salt is going to be the answer to this. Oil is a really good thing for these kinds of
When you go
experiments,
to the Dead
and I
Sea.
think that's a really, really good example. What's going on at the Dead Sea?
What?
What's going on at the Dead Sea? It's a really good example.
Split.
Water and salt. And what happens to people when they go inside? They float. Why? Who's denser? The water with the salt or the person, right? The water is denser. Exactly. And that's what we're going to do here. We are going to put in 4 tablespoons of salt. Okay. So remember our control? This is our control. This has nothing special. This has nothing special about it. Hey, guys, look at this.
Yeah.
Isn't that crazy? It's already got a really good head start.
Because it has a lot. It has the most.
That has the most sugar. That's exactly right. Let me just make sure this is staying on. Good. Okay. Next, what we're going to do in this one, we're going to add the same amount of water, but we're going to add 4 tablespoons of salt in addition. So let's make sure we have the same amount of water. I'm going to pour in the water.
We'll see which one floats the most.
Well, this one, we're going to try to get the egg to float. And then the third one we'll talk about in a minute. But first, let's get our 4 tablespoons of salt in there. Yeah, it's a lot of salt. Well, you know, we're trying to, and we're going to have to
Right,
mix it
little
too
ones.
because we need it to be a solution.
You can
Yeah.
again. It's just camouflage.
And 4.
Look at the water.
Okay.
It's camouflage. It
Now,
looks like limonada.
Let's
Yes, it
mix
does.
around.
That's white.
What if you drink it?
We got that one to float. And now, here's what we're going to do for this one. This is going to be our experiment to see how much we can add to get it to like half float. So, we're going to see
It won't
exact-
work if you're not going to take it out.
So that was 4 before. Let's try.
Two.
Yeah, but
Try
you also
2.
need to do
2 and a bit.
We also need to mix it is the problem. So I guess let's take it out. I think 2 and a bit is going to be necessary. I think 2 is not enough. Okay. So let's put it in.
Just don't crack the yolk.
Nope. It's at the bottom. It's at the bottom. So let's add some more salt. So far we're up to,
2.
yeah, this is about 2.
Take him out. Take the egg out.
here, it's in the middle. Wait, you didn't mix all the salt. That's at the bottom.
I didn't really mix it. So let's
Take
mix
it
it better.
out and then mix
The
it.
balloon got a bit bigger.
What got bigger?
The balloon got a bit bigger.
Nice.
A little bit.
The what got a little bit?
This one. And it also,
Yeah, the purple one, yeah.
it also moved.
Okay, so that was like 2. Let's do like 2.5. So that was a little bit more than half. What happened here? Let's take it out again so we can mix it. Oh yeah, you can sit there, yeah. There's also space on the other side, by the way.
Huh?
Dan had a really good idea. Maybe the different parts of the egg do different things, right? So he's going to crack the egg and pour in just the yolk, right? In the place.
Okay.
What did the yolk do? It fell down to the bottom, right? Okay. All right. So that answers your question. There you go. Okay.
I want to know what happens if just the yolks in here.
So that's not that the problem with that experiment is that you have air in there too, and air is less dense than air is a gas. What's denser? Almost always, what's denser? Any gas? A gas. Hey, Marianne, out. Marianne, please get out. Any gas is going to be lighter than any solid in general. That's in general. Of the same substance, a gas is going to be less dense than a solid. So here we have air compared to an egg. The air is, or water, air is going to be less dense than the water. Cool?
And what if I turn this to water? What happens?
That's an empty shell. It's air. It's air. So it's gonna float. It's gonna float.
Full of water.
It's gonna float. Now, if you could break off a piece of shell, let's look at our balloons. Let's look at our balloons here. So far,
It's getting bigger.
So bad.
For
So
some-
far, so bad.
for some reason, this is actually the least. I wonder if we made a mistake. Which one? Oh wow,
I don't know.
this is really tight. This is clearly doing the best. This is the second best, but these two are a little weird. Take a bottle cap. We don't have nothing to get it, so we're gonna take a bottle. Yeah, something like that. And we're gonna drill a hole. I got a drill here, and then we're gonna glue the cap to the CD, to the DVD. You see the hole in there?
I cannot.
There's a hole in here. There, watch your fingers. If your fingers are there, it'll. So the hole allows the air, when you blow up the balloon, it allows the air to come out slowly. And then there's air coming out. Now, if it's resting on the surface and there's air coming out, what's going to happen? It's going to float because there's going to be a thin cushion of air underneath the DVD. Right?
Normally when you blow up a balloon and then it will go all over the place.
Right.
But
And it's not
CD
controlled.
is like keeping it down and keeping it straight.
Exactly.
Why are you doing it on the coffee table?
We're going to do this on the coffee table.
Basically.
Okay.
Then we're
So you
going
guys
to the
wanna watch
coffee
it in action
table.
before we do it,
Can
before
you
we
make
make
it
our own?
move to
Here, let's see it in action before we do our own.
direction?
Now you can blow it up directly without taking off the balloon. Watch.
Yeah.
That's Pizza Hut.
Right? What do you think?
I think that it's Pizza Hut.
You ready?
Yeah.
gonna hover.
Go.
Not
Push it
hovering.
around. See,
It's not
floating around.
floating.
It is. It is.
It's floating.
It's floating around. And the reason why this is floating,
Oh yeah.
and watch now, does it float around like that now without the air coming out? No, not at all. Why is this not moving around like this?
Can I go
That's a good point. Yeah, because there's no, hold on, I'm asking a question. Why, the question is, why without the air does it not slide around?
Because the air isn't, because it's not, it's because it's not in the air and moving.
The air is
Yeah.
pushing down, so it throws it upward.
Yes, but why would it behave differently with air than without air? What's
Because
slowing
there's
this
no
down?
air to make it float.
Yes,
Gravity.
but what's slowing it down? Gravity is pushing it down onto the table.
So
And
it's really
why is it that when I push it, isn't it just moving forever?
Push it,
It won't move
Push
forever.
lots of air down, upward.
Okay, so you're in the right direction with the
If the table was made of ice, would it fly around there? Why?
What's the difference in ice
Slippery.
and slippery? Is another word for friction.
Yeah.
Guys.
Less
Yeah, you know about friction?
You know what friction is?
Everyone knows.
Aaron, what's friction?
Something that stops stuff from moving.
Yeah, it's when things touch each other, and so it stops them from moving. What's stopping this
Or
from
it can
moving?
make it go.
The reason why it can't go very far
Gravity.
is because gravity is making them touch each other, but there are molecules in this DVD, right? Are there molecules also on the table?
Of course.
What happens when they touch each other?
Friction.
There's friction, and they stop each other. So everything has a different amount of friction, right? We call it a coefficient of friction. Everything has a different amount of friction.
Can you
But
point out?
some things have less friction than others. Ice has less friction than this table, right?
Oh, then glass.
How much friction does air have compared to the table?
Zero.
Very little. Well, very little,
Almost
yeah.
zero.
So when there's air coming out, the air has no place to go but all out, right? And the air is coming out like this. And when the air is coming out like this, it pushes it up. So now the CD, the molecules of the CD, what are they touching? Are they touching the molecules of the table?
No, the air.
So please stop.
The air.
They're touching the molecules of the air. That's right. You ready? Or should we do it again? I'd rather, but this time we're gonna make our own, okay? Everybody push it around. It's like air hockey. This is how air hockey works.
And what?
Anybody play air hockey? We have some Canadians in the room. Some Canadians here. You guys know air hockey? Similar to your actual
I know air hockey.
Well, ice hockey is a similar idea. You want the puck to be able to go.
Ice hockey is harder.
We just made ourselves a new
Much
kind of puck.
harder.
Little puck.
Does
But it's a very difficult game to play because every 5 seconds, it stops and you have to blow it up again. I don't think it'd be a very fun game, right?
stop.
Let's make our own. You guys ready? Alright, you can sound the video. This is a drone. It's also called a quadcopter. It's got 4 rotors. Okay? And what happens is the rotors generate lift. Right? It lifts up the plane, the drone, and then it'll be flying in the air. And they can control it by making this one turn faster. So that'll fly a little better, and that'll control what orientation it's in. It controls what direction it's flying, right? So by changing,
a different way, turns a different side.
yeah.
If you make it slower, it turns it.
So if it turns a different way, it actually
Let's
would not
say
fly.
if it turns like this, or one of these propellers
Yeah.
will go slowly.
So also, you see the camera over here? Over here, this is for wireless. That'll send to like my phone the video.
Cool.
Yeah.
But then you should turn on the air conditioner. So it's like a spy camera?
It could be. Yeah.
Do a flip.
Should we try it?
Yeah.
Okay.
People use it on airplanes.
Let me make sure that I have enough battery. I don't know if I have enough
If
battery.
you stick a bomb on it.
Everybody
Put it on.
stand back.
Put it on.
Everybody stand back.
Okay. Nobody can be close to it. Please stand back. Everybody stand back more. Okay. You ready?
Yeah.
Like a vacuum cleaner.
Make a flip.
Isn't that cool?
Yikes.
Flip it.
So what's an important consideration when you're building a drone? If somebody built it, I didn't build this. So if somebody's building it, what kind of materials do you need?
Yes, you put
Yeah,
these.
plastic. So what's good about plastic?
A molecule. Another one.
What?
Another molecule.
What's important about the material that you use?
That you use
That would
correctly.
be not heavy.
That's exactly it. That's the most important thing here, right? We'd like it to not
Is it
heavy,
heavy?
but it
Weighs
can't be heavy.
nothing.
If it's heavy, it's not
Like
going to work.
feather.
Okay, everybody move back again.
It's
We're
a
going to try it again.
feather.
Oh, and you need to make it the same thing.
You have to move back. It's also running out of battery already.
Hey there.
This is a cool fan. You plug it in so it gets power, and the fan turns on, but it does something really cool. You ready? You guys watching?
Right. I knew it.
Whoa.
See that?
Yeah.
Yeah. Like a disc with the color. It's like a disc. Oh, so while you're working, you could like do.
Well, it's not supposed to be functional. Yeah, let's not touch it, okay? Let's not touch it.
Turn it off.
It's not. No. It's not. It's not
Yeah, it's going to waste
Stop.
battery.
It's not supposed to be functional. What it's supposed to do is it's supposed to teach a really cool idea. How are they able to make those patterns?
I don't know.
But it's one.
It's spinning very fast.
But you cannot
And what makes the light?
This,
Exactly. These are the lights. Now what happens?
It's like this, only that one is much cooler.
What happens if you could shine? If you know how quickly it's turning around. If let's say it's turning around 60 times per second. If you could shine a certain light, if you could shine one of those lights every 60th of a second, it's going to shine in the same exact place, right? If this is turning around 60 times per second, right?
Yeah.
And then you shine, please don't. And then 60 times per second, you shine the light. Every 60th of a second, you shine one of these lights. What's going to happen? Hold on. No, stop. Hold on.
It'll change.
Just hold on. I'm trying to talk. What's going to happen?
It will stay in the same place.
You're going to see the light
60 times per
in
second.
the exact same place. What can you do with that?
Oh, you can make the light stay in the same place like that, and then make different patterns.
And you can make different patterns.
Yeah, and it would be very hard to beat that
Or you can
fast.
make it move if you want, because you know how it works.
60 times in a second.
So that brings us to this one. Okay, this one does exactly what Shai just said.
But faster?
No. These are the different lights. If it knows, and it's got a little computer inside. Don't hold it like that. You gotta hold it straight. If it knows how quickly it's spinning, then it can flash a light that number of times per second, and that means that it's going to shine the light in the same place. Let's pretend I do this once per second, right? And let's say the light turns on once per second. Then one, go, 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 go. The light turns on. It's going to be in the same spot every time. And it looks like the light is constant over there. Let's see that in action. Let's see what it looks like.
It looks like you could charge it.
Yeah, there's a charger.
You could charge it?
That's how we get the...
Are
Are you ready?
It says you could charge it.
Yeah.
What does it say?
I can't read it. And
Science Camp 2016.
does
Science
that
Camp
say?
2016.
Whoa.
It does this by shining the lights
That is
on and off so fast, but in the exact same spot.
Having fun?
Copyrighted.
That's supposed to be a smiley face.
Can I buy that?
Yeah, you can buy it. It's like $5.
Really, really
Isn't that cool?
The face
The first. Is that what it
was
says here?
to. Really? What is it?
It's so clever.
Yeah. Does it say Teal? How do you post? How do you do it? This. How do you to explain how this? It says it's gonna explain to us how.
To explain how this works.
Works. Gets.
The first one to explain how this works. Get.
Okay, that's a very smart
We already explained
computer.
how it works.
That's true.
Did you write it?
I did. This one is hard to read.
What's
Anybody read it?
No. Yes. What's that?
Write something else.
Something candy.
Is this
Rock candy.
Rock candy.
That's that.
Yeah.
So.
You programmed it.
I did. Using this port on there.
What's it
To
hard?
turn it off. Who could explain? What we did the first time is we made rock candy. What we talked about was how you have something called a solution. Do we have on this table a solution that we made already?
Yeah.
Yeah, where are the solutions?
This, and
Yeah,
there.
those are solutions, that's right. Where things are mixed together in water with something else, right? That's water with salt over there, and here we have yeast with water. Okay. This is a solution. This is a solution. Here, you keep it straight. This is a solution of water and sugar. We made the water really, really hot. So hot that there was so much that the sugar was able to go into the water and become a super solution. At room temperature, that much salt, that much sugar could not have fit inside of the water. It was too much sugar to fit in the water, and you would have just seen a lot of sugar staying at the bottom. But by heating it up, now we were able to fit more sugar into the water. Now, it didn't stay hot. We took it off of the heat, so now it's cool. What happens when it's cool again?
It
All those
comes back to crystals.
All the sugar molecules, they don't know where to go. They
And they
can't
turn-
fit in the water.
They
There's too
turn back
much.
to crystals.
They turn back to crystals. So
And crystals are kind of rocks.
exactly.
Yeah.
And that's what happened here.
So why don't we call it crystal candy?
Let's take off some rock candy.
Why not? We can eat it now.
No, first I'm talking, okay?
then
Stop,
can I just-
don't interrupt.
Is it like a drink?
See this?
Yeah, that's what
This has water and sugar.
Hey, why is pink? Why is it
Well, we
pink?
put in some food coloring.
Oh, really? Why?
We thought it'd be cool. See that?
Wow.
This is after 3 weeks or 4 weeks.
So,
I think. Oh yeah, four.
Time.
Yeah. And
yummy.
For
what
just some
happened
rock
was,
candy?
whenever,
I would think.
shh, you guys have to listen. We seeded these sticks with some sugar on them, so that then the crystals would want to grow on those sugar pieces. that
and
were
on the
stick.
bottom.
And so that's what happened. The sugar started growing on the sticks, on the sugar molecules that we put on the sticks. Crystals started to form because there was too much sugar inside of the water. Didn't have any other place to go. It had to become a solid again. Couldn't stay as a liquid. So this is what we got.
But if it's food coloring,
So
why
why
that
is
is
it-
pink?
Oh, I don't know. I guess it didn't work very well. I don't know. I put in a little bit of food coloring. Maybe I had to put in more. I don't know. Okay.
Yeah.
Who wants
It
rock
probably
candy?
has to be
This is a special wire called Nitinol. It's made out of a material called Nitinol, which is nickel and titanium together. It's an alloy, iron, not so close.
That's strong.
So its properties that are interesting are not its strength. Something very cool, guys. You guys see the shapes? See what we have here? We have a 7 and a heart, right?
Yeah.
See the shapes?
More like a 1 and a half.
Yeah.
I think it's a
Or
7.
like-
Anyway, okay. See the shapes?
Foot backwards.
Yeah.
Who wants to volunteer?
Me.
Here.
But Daddy,
You
you
have the
can't
most
see
trouble.
the shape.
Okay, that's fine. I want you to do something with it so that it doesn't
Bend
look
it
like a
however
1
you
or a
want.
heart anymore.
Stretch it.
Anything you want to do, you could stretch it out. Obviously, don't rip it. Don't like pull it too hard.
Just like that.
However you want.
However you want.
Just connect them.
No.
Does this look like a heart?
No.
Looks
And
like a
one
bowl.
and a seven?
No.
Looks like a bull.
Looks like a ball.
It looks like a.
You guys ready for this?
Oh yeah.
I'm gonna apply heat.
Oh, I know
Make
what's
it
gonna
hot.
happen.
Okay?
Yeah.
You could drop it in the bowl though.
I'm predicting it's gonna happen.
I'm gonna apply heat. You ready?
Yeah.
And
What's gonna happen?
yeah.
You'll see.
It's moving on
Yup.
its own, right?
Magnetism.
What's going? No magnetism here.
No, no magnetism.
Why?
What do you see here?
A
7.
This is the 7.
No, it looks like I like.
This is the 7 that we had.
I like this backwards. It looks.
How did it do that?
I don't know.
I don't know either. I know, right?
Not really scientific.
What about the heart? Should we make the heart come back?
Yeah.
Should we apply heat to it?
Yeah. I need that. Oh, but didn't you want to go before?
Really cool.
Whoa.
Do you see that?
How did it happen?
I don't know. I have no idea.
Hey, Doctor.
How's that for a science camp director? Look at this.
Time, give yourself a break.
Who wants to try to deform it next?
Me.
It's got some memory. I'm not memory in the sense that a brain has. That's not possible.
No, it doesn't have a memory.
Right. But the molecules have some way of remembering
Molecules have
the
brains.
state that they were in, the shape that they were in, and then they're able to rearrange themselves.
You won't find it.
Aren't molecules stupid?
Molecules are stupid. They don't have a brain. Yeah.
How did he do that?
So, hey.
So now it's a little tangled, so we're gonna have to untangle it.
No, you cannot. Don't.
No, you see the 7.
Yeah, you do. You do see the 7 there. But
I won.
Okay.
okay, so here, so I made a hole through one side and then a hole through the other side, and I put 2 straws in there, and there's no gaps. I tested it. As long as I can tell, there's no major gap, so that the only way for water or air to get out of here is through the straw. Now, what's the air pressure inside of this bottle compared to outside of the bottle?
Higher.
So actually right now, it's the same. Right now it's the same because that's just what happens when you have 2 places that are connected. These are connected through the straw. The air pressure is going to tend to be the same. They're going to go to a place called equilibrium. That means where it's the same. But I'm going to do something to make the air pressure difference between the inside and the outside. You ready? I'm going to blow into the straw, and that's going to push more air. There's going to be more stuff in here,
And make bubbles.
more molecules. So what's important is not the bubbles, is the fact that there's going to be more pressure inside of the bottle than outside of the bottle. It's like it wants to explode. And what's going to happen is, after I take my mouth away and stop blowing, now the air pressure is going to want to be in equilibrium, right? It wants to have the same air pressure inside as outside. So air is going to want to go out of here, but the problem is air going to be able to get out? No. We have a straw in the water, so water is going to fly out. Okay? So once again, I'm going to blow inside. That's going to make the air pressure really high inside of the bottle. Okay? A lot of air pressure. But what does air pressure want to do when they're connected? It wants to be the same as everywhere. Air pressure wants to be the same. So the air pressure on the inside is going to say, hey, there's too many molecules in here and too little of a space. There's more space outside here. Why don't we go on the other side? Sorry. So what's going to happen is something has to come out of here so the water's going to come out. It's going to be a little bit of a fountain. You might get wet. I'm squeezing on here, so it's not able to come out, so I can blow in more.
Nothing on me.
Yikes.
Now.
Isn't that cool? The air pressure inside.
I know another thing. But that won't happen.
Hold on, we'll talk about that.
Would that happen if the water was full?
If the water is full, same thing, because
I think it won't because the water has no. I think it won't because the water has no space to jump in, so it would. If like the water is full to the end. With the same thing.
Oh, I get. Okay, so if the water was all the way to the top, and I tried breathing in air, so then I'm not sure that the air would be able to compress. Yeah, water wouldn't be able to compress. You're right. So we need to have enough air so that the air can compress when I blow in, so there's space for the air. It's hard if we try to push more water. If it's all the way full with water and try to push more water, that's much harder to do. So, yeah. Yeah, so that's the same idea. Okay, I just wanted to point out that so far the best one is a bottle that had the most sugar. That you put on. It had 3 teaspoons of sugar.
No, 4.
4? No, 3.
Three.
And it blew up the most. And then the one that had 2 blew up the second most. And the one that had none. Isn't this? I don't know. I don't really understand that.
None.
It could be. You know what it could be?
It is a none. See, because it doesn't have any bubbles like these.
Right. So you know what could have happened here? Maybe when we put it on, it already had some air in it, but not that much though. I don't.
No. Say how it happened. One kid took it, did that. Turned it up.
So they shouldn't have done that. Also here, this didn't do it at all, and it could be because I didn't pop out all these dents in the bottle. So I should have done that. I did that for the other 2, but I didn't do it for that one. So then when this gets more air, it'll just pop out the dents instead of blowing up the balloon. So that I did wrong. Okay.